partial differential equations. In short, we write PDE. Here we consider a function u. U is a function of x and y. U equal to u of xy means u is a function of x and y. Therefore, u is called a dependent variable and x comma y are called independent variables. Then we have the partial derivatives dou u by dou x, dou u by dou y. These are called first partial derivatives. In short, ux, uy are the first partial derivatives. Second partial derivatives or second order partial derivatives are uxx, that is dou square u by dou x square. That is, we are differentiating u partially with respect to x two times, dou by dou x of dou u by dou x. Similarly, uyy is equal to dou square u by dou y square, that is dou by dou y of dou u by dou y. And mixed derivatives that are second order, two times differentiation, that is second order. Mixed means first with respect to y and then with respect to x, or first with respect to x and then with respect to y. That is mixed partial derivatives. And the second order also, uxy is equal to uxy. That means with respect to y differentiating ux, that is dou by dou y of ux. And what is ux? Dou u by dou x. That in short you can write dou square u by dou y dou x. Okay. Then uxy notation means dou square u by dou y dou x. First with respect to x, then with respect to y. First with respect to x, then with respect to y. Okay. Here uyx means first with respect to y, then with respect to x. That is dou square u by dou x dou y. These are all called second order partial derivatives. Okay. Next, we consider an equation of the form a dou square u by dou x square plus b dou square u by dou x dou y plus c dou square u by dou y square plus d dou u by dou x plus e dou u by dou y plus f u equal to g. This type of partial differential equation is a partial differential equation because it involves partial derivatives. And the order is that first with respect to x, uxx, then uxy or uyx anyway. Third is uyy, and fourth is ux, and fifth is uy, and then u equal to g. And here a, b, c, d, e, f, g are functions of x and y, any functions of x and y or constants. And if this right hand side g equal to 0, then the equation is called homogeneous equation. It is not equal to 0, it is called a non-homogeneous equation. And this equation as a whole is called linear partial differential equation of second order. Here highest order is second. The linear second order partial differential equation. So most general form of linear second order partial differential equation. And its solution is always a relation connecting dependent variable and independent variable. U is equal to u of xy. If this satisfies this, then it is called a solution. Okay. These are the preliminary things that we want to know in this chapter. What is a partial differential equation? What do you mean by a solution? What are the notation for first order and second order derivatives? Okay. Next, we come to how we can find solution. Given a partial differential equation, how we can find the solution? Solution is u equal to u of xy. U is a function of xy. How we can find or how we can solve a partial differential equation? Here the method used is separation of variable or product method. This method is called separation of variable. Separation of variable or product method. In this method, we take the solution or assume the solution as u of xy is equal to a function of x, capital X of x, a function of x into a function of y. Capital X denotes a function of x and capital Y denotes a function of y. That is, we have separated the solution into two. First a function of x and then into a function of y. That is why the name separation of variables. And it is a product. x into y. Therefore, this is also called a product method. In this case, to solve a partial differential equation, we use this method, and this method first we assume u is equal to xy. U of xy is equal to x of x plus into y of y. And to find this solution, we have substituted in the equation. For substitution, you may need partial derivatives ux. What is the meaning? Dou u by dou x. Then dou u by dou x means we are treating the other variable as constant. With respect to x, when we differentiate with respect to x, we are keeping the other as constant. Therefore, this is, we treat it as a constant, that left fixed, no change. But we take the derivative of this x dash. X dash. This derivative of u, that is product xy into with respect to x, that is ux is x dash y. Similarly, uy means differentiating x into y with respect to y, then this x is constant. So function of x is constant there. With respect to y, when we are differentiating with respect to y, function of x is constant. Therefore, this x is constant, left fixed, no change. But differentiating this with respect to y, we write x y dash. Okay. Similarly, what is uxx? Again differentiating ux with respect to x. Then again y is constant because y is a function of y. We are getting x double dash y. Similarly, uyy is equal to xy double dash. Okay. These are the notations we use to solve a partial differential equation by using the product method. We are assuming solution as u is equal to x into y, and for ux we write x dash y, for uy we write x y dash, and uxx we write x double dash y, and uyy we are writing x y double dash. Okay, these are the things to be taken to solve a given partial differential equation by product method. Okay, now we can come to a problem, simple problem. Dou square u by dou x square. Problem is dou square u by dou x square. Question is dou square u by dou x square equal to 4 dou u by dou y. To solve this by the method of separation of variables, we are assuming u is equal to xy. And to solve this, substitute in this. For that, we have to find uy and uxx. What is uxx and uy? That are the two things to be found and substituting in the equation. Okay, then u is equal to xy means what is ux? X dash y, and uxx is x double dash y, and what is uy? Y is x y dash. Substitute here. Substituting in the equation, we are getting x double dash y is equal to 4 into x y dash. Substituting in the equation. And substituting, then next step is to separate into one side into x and one side into y. Here it is possible. Here x double dash is x here. You can take this to this side, and x double dash by x equal to remaining is 4y dash here, and the y from here is coming to denominator. This is separation. Separate into say function of x and this is a function of y. Separate. And that these two are equal means, when these two are equal, two functions are equal, then one is a function of x and the other is a function of y, and thus that two are equal means it is a constant. Therefore, it is, we take for convenience, it is minus lambda, a constant, minus lambda, because it is a constant because this is a function of y, this is a function of x. A function of x never equal to a function of y, only when if they are constants. Therefore, we take that two values, common values, as a constant. That constant we take for convenience minus lambda. Okay. Now we have got two equations. X double dash by x equal to minus lambda, one thing, and the other is 4y dash minus y is equal to minus lambda, two equations. Solving for x in this equation, we get a function capital X, and solving for capital Y from this, we will get capital Y, and getting x and y, we will get the ultimate solution u is equal to xy. Okay. Now consider this x double dash equal to minus lambda, that you can write as x double dash is to the side minus lambda x, and again to one side lambda x equal to 0. This is equation 1. X double dash plus lambda x equal to 0, 1. Or when taking this into separating into, sometimes you may take this 4 also, this 4 also to one side, this 4 also taken here for convenience. Okay, you can take this 4x equal to minus lambda, and this y dash y is equal to minus lambda. Okay, from this we are getting x double dash plus 4 lambda x equal to 0, equation 1. From here we are getting y dash plus lambda y equal to 0, number 2. Okay, 2 equations. And for solving each we consider 3 cases actually, because we have these 2 equations are equal to a constant. That constant can be 3 cases usually. One, that lambda can be 0, or lambda can be positive, or lambda can be negative. 3 cases. Case 1, we are taking lambda equal to 0. When lambda equal to 0, equation 1 becomes x double dash equal to 0. Equation 1 becomes x double dash equal to 0. When lambda equal to 0, second equation becomes y dash equal to 0. To solve, it is easy to solve this. When integrating and one differential cancels. Integration is opposite of differential, inverse. When integrating and one derivative cancels, you integrate one side. Integrating x double dash, you could integrate 0. What happens? Integral and one derivative cancels. Answer is x dash. Integral and one derivative cancels. The remaining is x dash. Integral 0 is constant. Suppose we take that constant equal to c1. Again, to get to x, again we have to integrate. Integral x dash equal to integral c1. Integral x dash means integral and x dash cancels x. X is equal to integral c1 is c1 outside, integrating with respect to x, because it's a function of x. c1 outside and integral 1 is x plus another constant of integration c2. Okay, thus we have got x equal to c1 x plus c2 as value of capital X. Similarly, from this y dash equal to 0, integrating both sides, we will get y. Integrating y dash means y equal to integral 0 is another constant c3. Okay, now what is solution? U is equal to x into y, that is c1x plus c2 into y is c3. Then c1 c3, that you can take some a1x plus c2 c3 is some b1. Okay, this is a solution. Some a1x plus b1 is a solution. U is equal to a1x plus b1. This is only case 1. Similarly, I have to consider case 2. Case 2 means lambda is greater than 0 or less than 0. Any case you can take. Case 2, we are taking case 2 as case 2 lambda less than 0. Therefore, let lambda is equal to minus alpha square. Alpha square being a square is always positive, and putting a negative, it will be negative. So for lambda less than 0, for convenience we are taking lambda is equal to minus alpha square. Okay, then what happens? 1 implies equation 1 becomes changed to x double dash plus 4 lambda x equal to 0. Instead of lambda we are writing minus alpha square, we are getting minus 4 alpha square x equal to 0. It's equation 1. Equation 2 changes to y dash plus lambda y equal to 0, means y dash minus alpha square y equal to 0. From these two equations, solving for x and y, we will get a solution. Okay, to solve this second order equation, usually we use auxiliary equation. For this x double dash we are writing m square minus 4 alpha square equal to 0. Auxiliary equation. Solving a second order equation, we take the auxiliary equation m square. For x double dash we are taking m square. For x dash we take m. For x we take nothing, 1. Okay. that is here m square minus 4 alpha square equal to 0. Then m square is equal to 4 alpha square. M is equal to root of 4 alpha square plus or minus 2 alpha. That is a case 2 alpha and minus 2 alpha are the values of m. That is different and real. Real and different roots. When we get real and different roots, how we can write the solution x? C1 or so you can take here C already we have taken up to C3. Now we can take another constant C4. C4 e raised to 2 alpha x plus C5 e raised to minus 2 alpha x. So solution x equal to some constant e raised to 2 alpha plus one root is 2 alpha m1x. This is m2x e raised to m1x e raised to m2x constant c1 c2. Instead of c1 c2 we are taking c4 e raised to m1x is 2 alpha x plus c5 e raised to m2x is minus 2 alpha x. Okay, thus we have got the value x. And from this equation y dash minus alpha square y equal to 0, you can change it into y dash is equal to alpha square y and y dash by y is equal to alpha square. Then integrating both sides. Integral y and in this numerator y dash derivative means the integral is ln y, ln capital Y. Denominator is derivative numerator means that integral is ln y is equal to alpha square is constant, alpha square integral with respect to y. Okay, alpha square y plus another constant of integration we are taking c6. Then what is y? ln y means base is e, then y is equal to e raised to something, e raised to alpha square y plus c6. This is e raised to this plus into e raised to this, e raised to alpha square y into e raised to 6. And this e raised to 6 is another constant. You can take that constant as c7. c7 is into e raised to alpha square y. Thus we have got a value of y also, x already got. Then what is the solution in this case? U is equal to x into y, x into y. That is c4 e raised to 2 alpha x plus c5 e raised to minus 2 alpha x into y is c7 e raised to alpha square y. Okay, now multiplying this and this c4 c5 c7 can take some a2 e raised to 2 alpha x into e raised to alpha square y, that is e raised to 2 alpha x plus alpha square y. Okay, plus alpha square y plus c5 into c7 is another constant b2 and adding e raised to minus 2 alpha x plus alpha square y. This is the solution in this case. And again one more case, case 3, lambda greater than 0, we take lambda is equal to alpha square. Again as in the above case, two equations are there, change it to one implies one equation, one changes to x double dash plus 4 alpha square x equal to 0. Second equation change it to y dash plus alpha square y equal to 0. Okay, now to solve this we use auxiliary equation m square plus 4 alpha square equal to 0 and m square is equal to minus 4 alpha square and m is equal to root of plus or minus root of minus 4 alpha square plus or minus root minus 1 is I, root 4 is 2, root alpha square alpha. It's a complex roots. When we get to complex roots, then we take that complex roots alpha plus I beta is equal to 2 I 2 alpha, and alpha equal to 0, beta equal to 2 alpha. Okay, and the solution is e raised to alpha x into some constant. Here you can take the constant as some c8 cos beta x 2 alpha x from some another constant is c9 sin beta x 2 alpha x. Okay, but alpha is 0 here and e raised to 0 is 1. Therefore solution is x equal to c8 cos 2 alpha x plus C9 sine 2 alpha x. Okay. And from here, you can see that y dash by y is equal to, taking this minus alpha square, and by y is equal to minus alpha square. And integrating, integral y dash by y is equal to integral minus alpha square. That is equal to ln y is equal to minus alpha square into y plus another constant, that you can take that constant as C10. Okay. So base E and y is equal to e raised to this e raised to minus alpha square plus C10. And e raised to C10 is another constant, that is suppose C11, and that is e raised to minus alpha square y. Okay, we got y also, x also, and multiplying u is equal to x into y. Okay, x into y multiplying, then we are getting that C8 cos 2 alpha x plus C9 sin 2 alpha x into C11 e raised to minus alpha square y. Then C11 into C8 is some constant A3 into e raised to minus alpha square y into cos 2 alpha x. C9 into C11 is some B3 sin 2 alpha x into e raised to minus alpha square. So solution. Thus, we have converted the answer for three values: lambda equal to 0, lambda equal to lambda less than 0, lambda greater than 0. Okay. And we have solved so many problems in the note. You just check that problems. Okay. Thank you.